Right, so we're going to have chemistry, like I said, and we want to start looking at organic chemistry. Now, this is obviously grade 12 organic chemistry. Now, there's a bit of difference between grade 12 organic chemistry and the A-level organic chemistry. Um, there, it's not so much of a difference, but there are a few details that we omit in grade 12 organic chemistry compared to the A levels organic chemistry, right? So we're not going to go too deep to look at the things for A levels, because remember, I also teach A levels. But we're not going to go too deep into the things for A levels. If at all at some point I'm going to teach organic chemistry for A levels, we're going to go deep into those things. But for purposes of grade 12 work, we're going to concentrate on what is necessary for grade 12. All right. So let's start with definition of organic chemistry. Now, what is organic chemistry? Now, when we talk about organic chemistry, really, we're just talking about a branch of chemistry that deals with the study of what are called organic compounds. Now, what are organic compounds? These are compounds of what? Carbon, all right? Now, when you look at most of these organic compounds, really, they most of them they contain carbon and hydrogen. However, they can also contain other elements such as nitrogen, oxygen, even things like chlorine, fluorine, and so on and so forth, right? So basically, we're talking about those that contain carbon, okay? But of course, there are exceptions. There are also what are called inorganic compounds that contain carbon. For example, when you talk of carbon dioxide is not an organic compound, but it contains carbon, isn't it? When you talk of things like calcium carbonate, all right, it contains carbon, but it's not an organic compound, okay? But generally, most of the compounds that contain carbon and hydrogen, they are what? They are organic compounds, okay? So in addition to carbon and hydrogen, there are also going to be all those other elements like oxygen, hydrogen, fluorine, bromine, chlorine, and so on and so forth, all right? So now, when we're looking at this organic chemistry, which is the study of organic compounds, we're also looking at their properties, their structures, okay, chemical and physical properties, the structures, and so on and so forth, okay? So that's what organic chemistry really is all about. So as we proceed in this topic of organic chemistry, much of what we're going to be looking at, if you concentrate very well, you're going to find that we're going to be talking about compounds of carbon containing other elements as well, like I have mentioned, and then we're going to be looking at their structures, their molecular formulas, their molecular structures, their structural formulas, the isomers, and so on and so forth as we proceed. Okay, so let's try to write something from what I've said. So, like I've said, we're saying that organic chemistry. So please feel free to ask questions were not clear. Organic chemistry is the study, or rather is the branch of chemistry, okay, of chemistry that deals with the study. Now, I hope my handwriting is clear enough. I hope you are able to see with the study of carbon compounds, okay, carbon compounds called organic compounds, okay. So I said that most organic compounds contain carbon, okay. Rather, we can say all organic compounds contain carbon, right? And then in addition, they may contain other elements such as hydrogen, oxygen, nitrogen, fluorine, etc. Okay, so they may contain all those elements. Okay. So that's organic chemistry. Now, let's look at what is called a homologous series, right? Homologous series. Okay. Now, I mean, compounds belonging to the same family. Now, when you're dealing with organic chemistry, we look at families of compounds, okay? Families of compounds with similar structures and probably similar chemical properties and so on. They belong to a family, to one family called the homologous series, okay? So a homologous series is a family of organic compounds with similar properties, okay, with similar properties. So I say that compounds with similar properties belong to the same family called the homologous what? The homologous series. Okay. They belong to the same family called the homologous series. Now let's look at properties of a homologous series, right? Properties of a homologous series. Now, what are some of the properties of a homologous series? Okay, so number one, uh, compounds that belong to the same homologous series, like I have mentioned earlier, they contain, or rather they have the similar properties. Okay, now when we talk of chemical reactions, for example, reactivity decreases with the number of carbon atoms. Okay, so if you have two compounds that are belonging to the same homologous series, and then we find that one of them has more carbon atoms than the other. Okay, one of them has more carbon atoms than the other. All right, so Gift, what you can just do for me is, if you're somewhere where there's noise, you can just please mute yourself, and then if you need to ask a question, you can unmute yourself. If you check just down there, there are those buttons. There's a button for like for phone call. There's a button for video, and then there's a little icon for a microphone. I don't know if you see it. So you can just click on that so that you mute yourself. Perfect. So that there's not so much noise. All right. So I'll say that compounds that belong to the same homologous series, they have similar chemical properties as well as physical properties. Now, in terms of chemical properties, we say that compounds in the same homologous series, the reactivity decreases with increase in the number of what? Carbon atoms. So, for example, if we have compound A and we also have compound B, right? And then this compound A has, let's say, 3 carbon atoms, all right? And then compound B has, let's say, 7 carbon atoms, all right? So which one would you say is more reactive than the other? Definitely, we are going to say that compound A is more reactive than compound B, because compound B has more carbon atoms. So the higher the number of carbon atoms, the lesser the reactivity, okay? Otherwise, the reactions are going to be the same, they're going to be similar, except that the one for compound B is going to be very slow due to that number of what? Carbon atoms. Okay, so we're saying that reactivity decreases with increase in carbon atoms. Okay, reactivity decreases with increase in carbon atoms. Then number two, what is the other property of compounds that belong to the same homologous series? Okay, I almost said homologous chromosome because of biology. Now, the other thing is that melting point and boiling point, all right, they also increase with increase in the number of carbon atoms. So a compound that has more carbon atoms will have a higher boiling point and a higher melting point, right? So melting and boiling point increases with increase in the number of carbon atoms. Okay, so melting point and boiling point increases with increase in what? In carbon atoms. What else? Okay, what other property of compounds belonging to the same homologous series? Number three, we say that uh, compounds with fewer carbon atoms, all right, they are more volatile. Now, what does it mean when we say volatile? When we say volatile, it means that it's the ability of a substance to evaporate. Okay, so those compounds that have fewer carbon atoms, they have more ability to evaporate. Okay, so it means that if you leave them, if they are both liquids, all right, if they are both liquids, then the one with fewer carbon atoms is going to evaporate faster, or rather easier, than the one with more carbon atoms. All right, so we say that compounds with fewer carbon atoms evaporate easily than those with more carbon atoms. Okay, is that fine, Gift? Are you following? I hope you're able to see. I think my marker is getting faint a little. I hope you're able to see. All right. All right. Cool. So if you're not clear, please always make sure that you ask. Right. Then what else? So I'll be changing. I use blue. I use black. Sometimes maybe green. Okay. Then the other thing about compounds belonging to the same homologous series is that they have the same general formula. Or the molecular general, they have the same general formula. Okay, they have the same general formula. All right. So we're going to be looking at all these, especially when as we talk about general formula. We're going to be looking at these in more details with time. Right. Then number five, probably the last. They have the same. They have the same functional group. All right. They have the same functional group. Now, what is a functional group, right? What is a functional group? A functional group is simply an atom or a group of atoms that is directly involved in the chemical reactions of a compound. Okay, in this case of an organic compound, right? So most of these compounds, they're going to have that what is called the functional group, which is simply, it can either be one atom or it can be two atoms or more than two atoms, right? that is directly involved in most of the chemical reactions that are involved, or rather that concern that particular compound, right? So they are all compounds belonging to the same homologous series. They are going to contain what is called a functional group. All right, they are going to contain the same functional group, and that's what is really going to determine the what the name, even the name and all the other properties of that particular compound. Right. So now, um, so that's basically an introduction. So maybe let me define functional group. Okay. So this is basically an introduction to organic chemistry. So what I'm going to do is I'm going to do two videos, an introduction to organic chemistry, and then we're going to start looking at the different homologous series. So then, so we're saying that a functional group is a group, is an atom. Okay, we're going to say it's an atom or group of atoms that is directly involved in chemical reactions of an organic compound. Okay. Now, we have looked at basically this introduction. Now, I want us to give some examples of these homologous series that we have. All right. I want to look at some homologous series. So, we say examples. Now, like I mentioned earlier, we're not going to be going too deep or talking about things that are not so necessary for the purposes of grade 12 chemistry. Uh, we're going to concentrate much on what concerns grade 12 chemistry. Now, number one, we have what are called hydrocarbons. All right, we have what are called hydrocarbons. Now, when you look at hydrocarbons, these are compounds that contain carbon and hydrogen atoms only. Okay? They contain carbon and hydrogen atoms only, nothing else, right? Nothing else. Now, what falls under hydrocarbons? Now, what we have under hydrocarbons, we have alkanes. All right? We have alkanes. We also have what are called alkenes. Then, now, by the way, like I've mentioned again, these are the ones that we concentrate on in this case, in the case of grade 12 chemistry, organic chemistry. But we also have what are called alkynes, we also have aromatic hydrocarbons, cyclic hydrocarbons, and so on, right? But for purposes of this lesson, we only concentrate on these two, alkanes and alkenes. Then number two, we also have what are called alcohols, all right? What are called alcohols, all right? And then number three, we also have what are called carboxylic acids. And then number four, we also have what are called esters. All right. So these are the homologous series that we're going to talk about for purposes of this lesson. Then after we're done with this, we're going to look at what are called macromolecules, or rather polymers. Okay. Polymers, not really homologous series of its own. Yeah. So these are the homologous series that we're going to concentrate on. These are also really considered as homologous series. So we're going to talk about alkanes, and then we talk about alkenes, then alcohols, carboxylic acids, and esters, and then later on we're going to talk about polymers. All right. we're going to talk about polymers. So maybe let me also just give an outline of polymers, how we're going to talk about polymers, and then I'm going to end that video so that we can probably start another one. So under polymers as well, it has 5 polymers. All right. So polymers, again, here we have what are called natural polymers. Natural polymers. And then we have what are called uh, uh, synthetic polymers. Then under synthetic polymers, again, we have what are called addition polymers and what are called condensation polymers. Okay. So this is basically the outline of our topic, organic chemistry. All right. So we're going to talk about alkanes first, and then we go to alkenes. Then from alkenes, we're going to talk about alcohols, then carboxylic acids, then esters. Then from there, we're going to start talking about polymers. Under polymers, we consider natural polymers and synthetic polymers. When we say natural polymers, we're talking about those polymers that naturally exist in the environment. All right. For example, things like proteins, okay, or maybe carbohydrates, and so on, and lipids. Those are natural polymers. Okay. Then we're going to talk about synthetic polymers. Those are polymers that can be synthesized in the laboratory. Okay, they can be made in the laboratory or in the industries and so on. Then under that we have addition polymers and condensation polymers. Now, when we say addition polymers, really this is where it's simply adding these smaller molecules together without producing anything else. Okay, so you add them together to form a long chain of those small molecules. Okay, but nothing else is produced. But in the case of condensation polymers, you're adding some small molecules together, and then in the end, you're also producing a byproduct such as water. So that is what condensation polymers are. So we're going to talk about these in more details. This is basically just an outline and an introduction to organic chemistry. All right. Is there any question before we proceed? All right. So I'm going to end this video here, and then I'm going to start another one.